Hello YouTube viewers, hope you're all doing good. Welcome to this video. I'm Venkat and this is just me an open source channel. Right, in this video I'm going to show you a quick demo of WeaveScope. So I came across this tool recently. So this is about monitoring and visualizing your Kubernetes cluster. So using WeaveScope. So Scope is a product by WeaveWorks, and it can help you monitor and visualize your resources in your Kubernetes cluster. It might come handy. So I've been using that, and it's quite useful to drill down the individual resources and what it's doing. It's more or less like a dashboard. Yeah, it's quite useful. I've done a video on Kubernetes dashboard UI a long time ago, but that's very preliminary. And I exposed you to Rancher, by which you can manage multiple clusters. So this is not either of those, but this is something you want to visualize, something you use to visualize your Kubernetes cluster, what's going on in your cluster, and what's using the CPU, which part is using more resources, and so on. So the cool thing is you can use that to gain access to your pods, containers. You can look at the logs of your individual pods. You can get a shell inside your container and so on. So it's gonna be very useful. So and it's very simple to install in your existing Kubernetes cluster. It's just a single command. I'll show you, and there you go. So you'll have your entire cluster monitored and visualized. Okay, so I've got my Kubernetes cluster set up in my LXC environment. So if you want to follow that, I've done a video on that separately, how to create a Kubernetes cluster using LXC containers. So if I show you kubectl version minus minus short, so server version is 1.14.3, although version 1.15 has been released. I couldn't get it working in the LXC environment, so I locked my LXC environment to Kubernetes version 1.14.3. So I'll be working on that, and I'll soon release an update to my GitHub repo for that Bootstrap script for LXC containers. But uh, that doesn't matter. Whatever version of Kubernetes you use, whatever recent version of Kubernetes you use, this should work perfectly fine. And the client version, the kubectl binary, is 1.15.0, which is latest. Okay, kubectl get nodes. I've got 3 nodes, 1 master node and 2 worker nodes. All of them are CentOS 7 containers. Okay, so I'm gonna switch to a web browser, and I'm gonna show you WeaveScope. Introducing WeaveScope. So it can be run as a standalone. So if you've got a Docker environment on your machine, you can run WeaveScope on your machine. But this demo is all about installing WeaveScope in a Kubernetes cluster and monitor and visualize the entire cluster. Okay, so you will get a dashboard similar to this. So individual nodes and how each nodes are connected to each other. So when I say node, nodes are just objects. It can be pods, controllers, resources, deployments, services, individual processes, and so on. And how each of the objects are connected to each other in terms of how what communicates with each other. So when I start my scope dashboard, you will come to know how each of these objects are connected. So that's how you visualize. So where the connections are coming from, where the connections are going to, and all those things you can visualize. And something like this. Okay, so let's go ahead and install WeaveScope. Installing WeaveScope, the link on the left. So I've got different installation depending on where you want to install WeaveScope. So I'm going to go with Kubernetes here. And they've got a command to run if you're running this on a Google Cloud in GKE, Google Kubernetes Engine. But I'm running it on bare metal, so I don't need that command. All I need is just this one. I'm going to copy that, go back to the terminal, and I'm going to paste that. Okay, so that's going to deploy a lot of resources into your Kubernetes cluster. It's going to create a new namespace called Weave and it's going to deploy all the resources inside that namespace. So in the end, if you want to delete it, if you just delete that namespace, everything will be gone. Okay, so before actually running this command, let's do a dry run to see what it's going to deploy. Okay, so we've passed the minus minus dry run option. So just to see what it's going to do with our cluster. So it's going to create a namespace Weave. It's going to create a service account called WeaveScope, a cluster role and a cluster role binding for that service account. So that service account needs to list, create, and so on. All those um, authorizations are needed. So that's what we are creating: cluster role binding. We're creating a deployment WeaveScope app. So that's the actual application. And we are also deploying a cluster agent and a scope agent. Scope agent is deployed as a daemon set because the scope agent is the one that sits on all the individual nodes and monitors the containers, pods, and so on. So the scope agent needs to be run on all the nodes, so it's deployed as a daemon set. And we also create a service for the app so that we can access the service. By default, it's going to be created as a cluster IP, so you won't get access to the service. You have to do some magic to gain access to the service, which I will show you. Okay, so these are the resources it's going to deploy, and we've inspected them. And now let's go ahead and deploy those. Okay, so that's done. If I do kubectl get namespace, Weave namespace got created. Let's do watch kubectl -n weave get all. So the containers are getting created. As you can see, there's a service, a daemon set for the agent, a couple of deployments, and the replica sets for the deployment and daemon sets. Okay, so all of them are running. The images are quite small, so it didn't take a long time. Scope agent, app, and the cluster agent. So that's all it has done for us in the cluster. So we are good. And if you look at the service is of type cluster IP, and you won't be able to access this service outside of the cluster. So to make it run outside, to make it accessible from outside, there are a few options. You can change the service to node port so that you can access it from any of the worker node, or you can change the service to load balancer type if you've got a load balancer set up in your cluster environment. Okay, so I'll show you both the ways. So the first thing is I'm going to deploy it as a node port if you don't have a load balancer set up. Okay, so by the way, if you want to set up a load balancer, I've done a video on that. It's called Metal LB Kubernetes. If you search for Metal LB Kubernetes, hopefully the first video will be mine, set up Metal LB load balancing for bare metal Kubernetes. If you follow that video, it's a simple one, and it's only 11 minutes long. My videos are about 30 minutes, and this one is a short one, so you can get that working fine. Or if you don't want to watch that video, that's okay, because I've got a documentation in my GitHub repository, github.com just me and open source /Kubernetes. I'll put a link to the description of all the URLs I used in this video in the YouTube description. Okay, so in my Kubernetes repository under docs, set up Metal LB nodes. So if you don't want to watch the entire video, basically it's just these two commands. We are creating the Metal LB deployment. That's the first command. And then we are creating a config map. You can see the kind is config map. So the config map is telling the IP address range of the IP address range that the load balancer should use. Okay, so let's do that. Let's first go with the load balancer type to access it from outside, to access the service from outside. And then for those of you who don't have load balancer or don't want to do the setup, or you want a quick way of testing the service, you can use the simple node port service, which I will show you in a minute. Okay, first let's run this command. Control C, Control V. So MetalLB, it has created all these resources, and it has created a namespace called MetalLB. kubectl get namespace. So there is MetalLB, kubectl minus n MetalLB system get all. Okay, so already all the pods are running. So now we have to do the config, create the config map. Okay, but I'm going to change the IP address. I'll show you what needs to be changed. Okay, so before that, the IP address here, 172.424.2. The IP address range should be in the same range as of your worker nodes. So what's my worker nodes IP range? kubectl get nodes minus o wide. So all my nodes are in 1092.250 network. So that's the range that I'm going to use. Okay, so paste that, and I'm going to change that to 1092.250.220, for example. And again here, 10.92.250.200. So I'm saying that the load balancer needs to assign the IP address in the range 1092.250.200 to 220. I'm just um, assigning like 20 IP address for the load balancer. So the load balancer will pick up IP address within this range. Okay, so that's done. And close the here document EOF. Okay, config map is now created. So now we are good to change the service to a load balancer type. kubectl minus n weave get service. So now WeaveScope service is of type cluster IP. So now we're going to change that to load balancer type. kubectl minus n weave edit service name is WeaveScope app. And if you go to the bottom of the output here, the type is cluster IP. So I'm going to change that to load balancer. Save the file, and the app was edited. So if I do the same command again, kubectl minus n weave get service. Okay, now you can see the type is load balancer and the external IP is 1092.250.200. So it has picked up the first IP address of the range that we defined. So now we should be able to access this IP address, that's the load balancer's IP, from our web browser. So copy that, go to the browser, and paste it. Okay, cool. So that's the WeaveScope dashboard. So let's go through the dashboard. It's not much, but you can see, you can play with it, and then finally I'll show you the node port thing instead of load balancer. Okay, so WeaveScope. So that's the dashboard. Uh, you can define the views. You can change the layout by choosing which resource you want to visualize. So at the moment it's showing the controllers. Controllers are deployments, daemon sets, and so on. And in the bottom you can see now it's showing the controllers from all namespaces, right? So if you want to change that to default, because we haven't got any controllers, any deployment or daemon set in the default namespace, it's empty. And if I select Kube system namespace, for example, and I unselect default, so Kube system, the controllers in the Kube system here, you've got core DNS, Flannel, Kube proxy, and all those things. So that's a nice view. And then by name, so Kube scheduler, core DNS, that's the API server. So these are called nodes, right? So nodes are just objects. It can be pods, deployments, controllers, services, processors, and so on. And edges. So this is called a topology, and the topology is consist of nodes and edges. And edges are the connections. So how are these connected? If you see Kube API server, all the connections from all the nodes above are coming into Kube API server. So that's how the Kubernetes cluster works. So all the interactions are through the API server. So all the connections from all the nodes are coming into Kube API server, And then Kube API server talks to itself. So that's the line here. And then Kube API server has also got an outgoing connection to the data store, the etcd. Okay, so you can click individual items. So if I click Kube API server, you see how these are connected to each other. And on the right, you can see the inbound connections. So connections are coming into Kube API server from kubelet, kubeproxy, flannel, controller manager, speaker. Speaker is the metal LB load balancer component. Outbound. So Kube API server is talking to the etcd server on port 2379, and the API server is talking to itself through the API server on 6443. And the process is Kube API server, and the PID of the process inside the machine that's running the Kube API server is 4262. And here you can see the CPU utilization and memory utilization of that process. Okay, so what else can you do? Let's see processes. Okay, and you can zoom in and zoom out. And if you click Kube API server, again, you see all those things. And here you see the CPU utilization, memory utilization, number of open files, and all these details. And you can, so now you can look at the CPU utilization of the individual components. So if I hover over CPU, or if I select CPU, so now it says 0.12%, and you can also see inside every node what's the utilization, what's the CPU utilization. And if I hover the mouse over the Kube API server, it will show the CPU utilization of all the nodes as well. Okay, and if you choose memory, and you can see the individual memory used by all the single components that talk to the Kube API server. So it's all in here. So 31.7 meg, and the controller is using 100 meg, and the Kube API server is using 283 meg. So that's the number of open files, and you can see Kube API server has got 103 open files, and all the other nodes have, it shows the number of open files it has got. So apart from that, so that's the pod view, and you can also look at the layout in the table view. Okay, so let's look at the memory, and you can see Flannel is using more memory. That's the Flannel, that's the Flannel. Okay, and the other ones are not using as much memory. And if you want to look at the CPU, there's a small line down the diagram, down the node, that shows you the CPU utilization, memory utilization, and these are all for the last 15 seconds, right? Okay, so you can switch to the table view if you want, and you can see here the CPU utilization, memory utilization of the pods, graph. Okay, so let's go back to controllers, and if you want to dig, you can look at one of the controller, and it gives you details about that controller, all the details about that. And there is also this little icon here called describe. So if you click that, it's going to now, okay, daemonset.apps is forbidden user. So WeaveScope service account cannot get resource. Okay, so we must, I think we need to change the cluster role and cluster role binding so that it can list objects, daemon sets, and deployments from different namespaces as well. Okay, so hosts. So I've got three hosts: master, worker, worker one, and CPU is tagged, and you can see the CPU usage: 19.64%, 18.23, 1419, 1452. And if you want to see the 1 minute load average, it's a nice graphics there, and memory utilization. And you can drill down. If you click kworker2, it will show where the connections are going out, going in, CPU utilization, memory utilization, and the load, and all those things, and the pods that are running in the kworker2. So if you want to know how many pods are running in a specific node, you can use this. Okay, and I haven't tested this one, so there's a little icon here, exec shell. Let's see. Oh, cool. So we can get a login shell to the worker node. So I've logged into the kmaster ls. That's working fine. Closed it. Go to kworker2, kworker2, and I can get a login shell to that node as well. Okay. Containers. So these are the containers running within the pods, and controller, speaker. If you click on the control, one of the container, you can see you can pause the container, stop the container, restart it. You can look at the logs of the container. So there's no log for this container. That's okay. CPU, memory utilization, and information about the container, what image it's running, image name, and what actual command it's running. State. So it's up for about 10 minutes. The list of labels associated with this container and so on. And as usual, you can get a shell to this container. So we are inside that container now. If you want to debug anything, you can get a shell into the container. Okay, so now let's try and deploy a pod or a deployment Nginx application in our default namespace. So if I select the default namespace, at the moment, it hasn't got any containers. It hasn't got any. Now it's changed to the Kube system, so I'm going to change that to default and unselect Kube system. Okay, so we don't have any pods, we don't have any containers, we don't have any controllers, and we only have the default Kubernetes service. kubectl get all. So service Kubernetes, so that's the one. So we only have the default Kubernetes service. We don't have anything else. Process, that shows the list of all the processes. So let's go back to the pods. And if I select all namespaces, it gives you a nice dashboard. Okay, so that's the list of pods we've got. Let's close that. And this is updating live. So you can pause the update, and if you if you want to see the live dashboard, if you want to put that on a big screen, and you can do that. And if you select live, it will update automatically. Okay, so let's go back to the default namespace. Pods, containers, nothing. Let's try creating some. Okay, kubectl run nginx minus minus image nginx replicas 3. Okay, so that's created. And if I go back to the dashboard, you can see it has updated the diagram. So now we have 3 um, pods, and there is 0 containers because it's pulling the container at the moment. Soon it will show you the number of containers within the pod. So there's one container that's ready, one container that's ready, and one container. So all of these has now got the containers. So if I switch to the containers view, you can see all the containers, and you can see where they are running. So this container is running on kworker1. So these two are running on the kworker2 node. Pods and controllers. Now you can see that's the Nginx deployment of 3 pods. If you click that, so you can see basically all the details about the deployment. And you can also increase or decrease the number of replicas, scale up or scale down. So let's say we've got 3 pods, let's scale to 5 pods. 1, 2, and close that. And now you see deployment of 5 pods. Now if I go to pods, you can see 5 pods here. Okay. Default, and we've got 5 pods, and inside each pod, if you look at the pod, it shows the CPU and memory utilization, the current IP address, what's the state of it, and the actual process running within the pod, within the container. And if I switch to container, it has got 5 containers. You can select any of the container, and you can get a shell into that container. ls, we are inside the container. We can stop a container, stop, or let's say we stop the container. Okay, so that's stopped, and another container got created. That's how kubectl Kubernetes works. Okay, so there is this table view which you can use. Okay, so there is this resources tab. If you go to hosts, for certain type of objects, you can have the You can see the resources tab view enabled. For containers, we've got resources, and if you check that, you can select the containers, processes. I don't know why I can't select that. Uh, Containers, hosts. Okay, let's say hosts. KMaster, at the moment, it's showing the CPU usage, 18% used, 17%, and 16%. And that's the memory utilization. KMaster, KWorker1, and KWorker2. And you can see there's a little graph that's coming up. I don't know. I think if we leave it for a while, it will show you a nice graph, I think. CPU, and you can see a small line starting here. Containers and uh, the processes. So how much CPU the containers are using, how much CPU the processes are using, and so on, I guess. Okay, so now if I go to containers, okay, resources. All right, so I think we don't have anything else to look at in this dashboard scope. I also want to mention that you can extend this scope dashboard by adding your own metrics. So at the moment it's showing just CPU and memory utilization. You can add your custom metrics. So the way to extend scope is by writing your own plugin. So there is documentation about writing your own plugins, developing and debugging, understanding. I think it should be somewhere here. Understanding Weave. Okay. So there should be documentation here. They've also got some official uh, plugins which you can search in GitHub. GitHub WeaveWorks plugins. So WeaveWorkscope plugins. They've got 5 repositories. They've got 5 plugins basically. So scope HTTP statistics, for example, you can go there, and if you deploy that plugin, it's again a simple command to run in your Kubernetes cluster. So in Kubernetes, if you just run this command, and it will deploy the HTTP statistics pod as a plugin, and then you will be able to look at the metrics from your web server, like the responses, average request per second, maximum request per second, and so on. So similarly, so these are some official plugins, but you can also write your own plugin for gathering custom metrics into the WeaveScope dashboard. So you can, excuse me, so you can visualize and you can monitor what's going on in your cluster. Okay, so I think, um, okay, forgot to mention, forgot to show you how to do the how to use Noteport. Okay, let me close that, and I'm going to go back to my terminal. kubectl minus n weave get service. So now it's type load balancer. Let's change that to Noteport. kubectl minus n weave edit service weave scope app. Go to the end, change the type load balancer to Noteport. That's it. Changed. And if I run the same command again, so now it's of type node port, and the node port's IP, the node port is 32122, and you need to access it via one of your worker node. So kubectl get nodes minus o white. So kworker1 and kworker2, they've got IP address 1092.250.41. Let's take this one for example. Copy that, paste it in your browser, and the node port is 32122, I think. Yeah, so there you go. That's your WeaveScope dashboard. Okay, cool. That's all I wanted to show you in this video. And if any one of you watching this video are actually using WeaveScope or know about WeaveScope before this video and how you're using it, it would be useful for me as well as for other viewers to understand how you're actually using it. Is there anything that I missed to mention in this video? It would be helpful if you could mention that in the comments. And yeah, I think that's it for this video. Okay, thank you so much for your time watching this video. And if you liked it, please share it with your friends and don't forget to subscribe to my channel. And I will see you all in my next video. Bye bye.